Let's talk about finding the length of a vector that has three components. So here we have the vector v equal to 1, 4, 3, and I want to find its length. In a previous video, we graphed this vector, and I want to point your attention to the fact that we have a right triangle here. This dashed line and this dashed line form the base and the height of the triangle, and the vector is the hypotenuse. And I'll draw in a little square symbol so maybe you can see it better. There's a triangle there. It's a little bit at an angle to us, but it's definitely a right triangle sitting there. Okay, so knowing that, we can just apply the Pythagorean theorem. And the length of v is simply the square root of the base of that triangle squared plus the height of the triangle squared. So now all we have to do is figure out what is the base and what is the height of that triangle. Well, the height is easy. The height is how far we go up in z. And we're just going up 3 units in z. So the height is just simply 3. Okay, took care of that. This is b squared plus 3 squared. Now what about b? Well, if you look closely, you'll notice that there's another right triangle right here. And that triangle, or what I should say is B is the hypotenuse of this triangle that I've filled in with yellow. In fact, let me pull that triangle out. So this is the triangle I'm talking about. B is the hypotenuse. Once again, for clarity, this is the triangle that I've pulled out. It's this triangle here. Okay, well, what are the sides of this triangle? We know that we moved over 1 there and 4 here. So we can just apply the Pythagorean theorem again. And we can say that B now is equal to 1 squared, the square root of 1 squared plus 4 squared. That's what B is. Well, now that we have a term for B, let's go ahead and plug that in. So we have B, which is the square root of 1 squared plus 4 squared. And now B is being squared. And then plus 3 squared. Well, something really nice just happened. Look, we have a square root being squared. And so that square root just simply goes away. So this whole thing simplifies to the square root of 1 squared plus 4 squared, because that square root went away, plus 3 squared. Now compare that to the components of v. You'll see that the length of v is simply the sum of the square root of the sum of the squares of the components. And that's kind of a lot of words to say all at once. But we just take each component, we square it, we add them together, and we take the square root. Okay, let's do another example. Let's say we have u is equal to, I don't know, 1, -6, 4. What is the length of u? Well, we don't need to go through the whole process that we went through. We can just remember, as long as we understand what we did, we can just remember that the end result is just going to be, we take each component, we square it, we add them all together, and we take the square root. So simply the square root of 1 squared plus -6 squared plus 4 squared. And that's it. If you want, we can do another example. How about -3, 0, 9? So the length of w is equal to, oops, what am I doing? It's equal to the square root of -3 squared plus 0 squared plus 9 squared. And there you have it. There's the length of a vector with 3 components. If you're wondering what happens if you have more than 3 components, let me show you that quickly. And I might make a separate video about this, but let's say we had something like v is equal to v1, v2, v3, and v4. So now we have 4 components. The length of v, you might be able to guess what it's going to be. Is the square root of v1 squared plus v2 squared plus v3 squared plus v4 squared. And if you had 5 components, you'd do the same thing. You'd just tack that 5th one on at the end. If you had 6, you would do the same thing, just tack those on. So that's the vector length for vectors with more than 2 components. Okay, see you in the next video.